Good evening, everyone. Welcome here to First United Methodist Church. My name is Warren Pattison, and I have the honor and privilege of serving here as the Director of Adult Ministries. I'm so delighted to see so many folks who have come out here on a Wednesday evening in August. We've already had our tropical weather for the week, so... So we're delighted that you are here, and I see many faces that I know and some that I don't, and so I want to say a special welcome to our guests as we gather here today for what is going to be a wonderful and inspirational and very informative evening. We are delighted to welcome the Reverend Dr. David Wilkinson to be with us here this evening. Yes. Dr. Wilkinson holds doctorates in both theoretical astrophysics and systematic theology, so that already gets me excited, y'all. I mean, I don't know what else to say. This is an exciting time for me. Dr. Wilkinson's current work involves the relationship of the Christian faith to contemporary culture, from science to pop culture. His current interests include the media, preaching, missiology, and Christian communication. He is a regular contributor to BBC Radio 4's Thought for the Day. You can find that on the BBC's website if you would like. And travels widely to speak and to broadcast on the relationship of science and faith. He is in high demand worldwide as a preacher and Bible teacher. And I understand you were in India just not too long ago. Is that correct? Yeah. So from India to Florida, welcome. You brought the humidity with you, right? Dr. Wilkinson is the author and co-author of a number of books concerning science and the Christian faith, including Science, Religion, and the Search for Extraterrestrial Intelligence by Oxford University Press, When I Pray, What Does God Do by Monarch, and co-authored with David Hutchings, God, Stephen Hawking, and the Multiverse, What Hawking Said and Why It Matters. That title is available in our bookstore. I'll tell you more about that a bit later, and invite you to have an opportunity to come and to talk with Dr. Wilkinson and purchase one of his books if you would like, and he, I'm sure, would be happy to autograph it for you. In addition, David has written on spirituality and contemporary cinema with the book. This is what really excited me when Paul approached me about this, and I read this, The Power of the Force, the Spirituality of the Star Wars Films. And those of you who have ever been in my office and seen all of the Star Wars decor and the lightsaber that I keep hidden in my closet, you'll know why that excited me. And has also written a book on the Christian doctrine of holiness for a new generation, and a book entitled A Holiness of the Heart, and an exposition of the biblical themes of creation in a book entitled Creation from InterVarsity Press. So we are super thrilled to have Dr. Wilkinson here. I do want to say a special thank you to Paul Irvin, who brought this opportunity to me and encouraged us to make this a possibility. So y'all have heard me talk for long enough, so I'm going to sit down and turn it over to the Reverend David, Dr. Wilkinson.
Yeah. Warren, thank you very much for such a kind and generous invitation. In fact, so kind that I'm quite looking forward to hearing myself speak this evening. It's very generous of you, and very generous for you to host me, and very generous for you to give up an evening to listen to someone from the UK prattle on about the relationship between science and faith. I want to also echo the thanks to the Irvin family for looking after me in so many different ways. And I'm excited to be here. Some while ago, I was on a train, and on the way to London, I sat down. I live in Durham, about 240 miles north of London. And the person beside me wanted to start up a conversation, and he said, "What do you do?" Well, I said, I'm a theologian, and I'm an ordained Methodist minister, and whenever you say that to people, you never quite know what people's reaction will be. And this man's eyes seemed to fill with fear as he thought to himself, oh no, 3 hours to London beside a religious fanatic. He quickly tried to change the topic of conversation. He said, what did you do before that? Well, I said I did research in theoretical astrophysics. This time his eyes glazed as he thought it was something to do with science. He asked me a question that lots of people have asked over the years. How can you be a scientist and a Christian? For within Western culture, there is a sense in which science and Christianity are often put into conflict with one another. That's the conflict model, which actually comes from the 19th century and was created by a friend of Darwin's called Thomas Henry Huxley. And not only is the conflict model embedded in that phenomenon which we call New Atheism of Richard Dawkins and Dan Harris and others, but also today is embedded within popular culture. I'm a great fan of the Big Bang Theory. I mean, we'll come to the Big Bang model in a moment, but Big Bang Theory, the comedy series, you've come across it. And some of you will know that Sheldon Cooper, the central character, great physicist, and there is a spin-off series to the Big Bang Theory called Young Sheldon, which tells the story of how Sheldon Cooper grows up in six-day creationist Texas. And there, the young, brilliant physicist starts a relationship of friendship with his local pastor, Pastor Jeff. This is the first time that young Sheldon and Pastor Jeff encounter each other.
Sometimes people say to me, Pastor Jeff, how do you know there's a God? And I say it's simple math. God either exists or he doesn't. So let's be cynical. Worst case scenario, there's a 50-50 chance. And I like those odds.
That's wrong.
Shelley, put your hand down. Sorry, please continue.
It's okay, Mary. It's Sheldon, right?
Yes, sir.
Well, Sheldon, why don't you come on up here and tell me how I'm wrong?
No.
Okay.
Let's give him a hand, everybody.
What's happening?
Shelley's going to eat him alive.
So, you were saying?
You've confused possibilities with probabilities. According to your analogy, when I go home, I might find $1 million on my bed, or I might not. In what universe is that 50-50?
So what do you think the odds are that God exists?
I think there's zero. I believe in science.
So you don't think science and religion can go hand in hand?
Science is facts. Religion is faith. I prefer facts.
I understand that. Here's a cool fact for you. A lot of famous scientists believed in God. Isaac Newton, Albert Einstein, even Charles Darwin.
So Darwin's right about God and wrong about evolution?
Now you're getting it. Let's give it up for Sheldon, everybody. What a good sport. Oh.
But I wasn't a good sport. At that moment, I vowed to come back the following Sunday and destroy Pastor Jeff.
I'm going to suggest to you this evening that science and religion can engage with each other in a constructive way. You might want to wait till the question and answer session to destroy me a little later in comments, criticism, or question. That's what the question and answer session is. But my background is in theoretical astrophysics. That sounds great at parties. Most people say that's very interesting and move quickly to talk to the accountant at the other end of the room. But astrophysics is very simple. It's twinkle, twinkle, little star, how I wonder what you are. That's basically what astrophysics is. The only trouble is astrophysicists say, up above the world so high, a contracting ball of hot hydrogen gas undergo nuclear fusion. It doesn't quite scan in the same way of that. But in my work on stars and galaxies and the Big Bang model itself, I have to say to you that although there were difficult questions posed by science to faith, and from faith to science, some of which I don't still have the answer to, I found those questions not destructive but enriching, both to my excitement with science and my excitement with Jesus. And that's in some contrast to some of the ways that the media present this relationship between science and faith. In 1987, Stephen Hawking published this book, A Brief History of Time. He thought it might sell about 30,000 copies. It went on to sell 10 million copies worldwide. Carl Sagan in the foreword, I think, gave us one of the reasons for why it sold so much. Part of the reason was Professor Hawking's own remarkable personal story. But part of it, I think Sagan was right when he said, this is a book about God, or perhaps about the absence of God. But that sense that science leads to the absence of God is not the only voice. Around the same time, Paul Davies, also a distinguished cosmologer and popularizer of science in a series of books, said, in my opinion, science offers a surer path to God than religion. An absence of God or a surer path? Well, what I need to do in the short time that we have this evening is tell you a little bit of the story of the universe. Is that all right? So we'll talk about the universe, we'll talk about the origin of the universe, and then I'm going to suggest to you one of the fascinating things about those who work at the forefront of physics and cosmology, the origin of the universe, is that they find themselves asking theological questions. Not because they're people of faith or members of faith communities, but because the science itself raises questions about God, raises questions beyond science. So let's begin. Any of you seen the photographs from the James Webb Telescope? I hope you have. They're astonishing. And this was the Nature article on the day when Webb published its first pictures. Nature had the headline, "Astronomers are in awe of these photographs." And the first picture that came out was this one. This is a deep field here. Now, don't worry about these things here. They're just stars close to us. They're kind of minor, not terribly important. I want you to look at some of these blobs of light. These are distant galaxies. The light from them has taken about 13 billion years to reach us. Let me just say that again. The light from these galaxies has taken 13 billion years to reach us. The light from the sun, remember I'm from England, so I rarely see it, but the light from the sun takes about 8 minutes to reach us. The light from these galaxies has taken about 13 billion years. And the wonderful thing about this picture, do you see some of these little arcs of light here around? That's the distorted light from galaxies long, long way away due to something called the warping of space-time through general relativity. We might come back to that a little later. The second picture was this, and this is a wonderful picture. It's a maternity hospital for stars. A vast cloud of dusty molecular hydrogen that will lead to about 10,000 stars, each as large as our own sun. And the next picture is literally dancing with the stars, because these galaxies are revolving around each other in a beautiful cosmic waltz as gravity holds them and they rotate around each other. And so when we look at the universe, there's this sense of awe. This is a really special photograph, just came in a few months ago. This is the furthest astronomical object that we've seen. And it rejoices in being called JADES GS Z140. Astronomers have great imagination sometimes in naming galaxies. And it's a little bit of sky just here, which was looked at, and here's a galaxy, and the light from that galaxy has taken 13.4 billion years to get to us. So we're seeing that galaxy as it was 13.4 billion years ago when the light left it. It's an extraordinary thing. Within about 400 million years of the Big Bang itself, we're looking back. Let's show this in a slightly different way. And some of you will know this quite old animation now. It's called Powers of 10, but it still makes the point very well. What we're going to do is we're going to start with a couple having a picnic in a park. And we're going to expand the size of the picture by a factor of 10 every 10 seconds. So every 10 seconds, you're going to be 10 times further away from the picnic in the park, okay? Left-hand side of the screen. Oh, sorry, I did that wrong. Let me try that again, okay? I won't start the commentary again. You've got that already. I pressed the wrong button. On this side of the screen, tells you a distance scale, how many meters we've traveled. On this side of the screen is a mathematical way of writing the same thing. If you don't understand that, just smile as if you do. It'll impress everyone around you. And as we move through the universe, so you begin to see the universe at different perspectives, okay? You see different levels of structure. You've lost the sense of the picnic in the park. You now see a large city, a large expanse of water. Is it a big lake? Is it an ocean? Well, as you begin to leave the Earth's atmosphere in your rocket, whether it's an Apollo or Falcon, you begin to see the continent of North America beginning to emerge, and that's a great lake. We now left the atmosphere, and we begin to look back on our home, this beautiful blue planet, which we call the Earth, and just how special it is in the vastness of the universe. In a moment, you'll see a line extend horizontally across the screen. That'll be the true speed of light at this perspective. Okay, there it goes. That ellipse is the orbit of the moon, about 240,000 miles from the Earth. By the way, for those of you who are Methodists, that's the distance that John Wesley traveled on horseback, preaching the gospel. Funny coincidence, that, isn't it? This is now the orbit of the Earth. And remember, the Earth has some near neighbors, rocky planets. Here is the orbit of our near neighbors, Mercury, Venus, Mars, our hot ball of hydrogen gas undergoing nuclear fusion, our local star, the Sun. Now these are the orbits of the outer planets, big gas giants, Jupiter, Saturn, Uranus, Neptune. This movie is so old, it even has the orbit of Pluto on it. Most of us believe that Pluto isn't a planet, just a bit of rock that got lost. But anyway, we're now moving through a vast cloud of comets called the Oort cloud. So small you can't see them, but millions and millions of comets on the edges of our solar system. It was a disturbance in these comets about 65 million years ago that we think led to the dinosaur extinction. If you draw the constellations onto the sky at this point, they would look exactly as they do from the surface of the Earth, because the background stars are so far away from us. You might have noticed we've run out of space on the left-hand side of the screen, no pun intended. We're now talking about the distance that it would take light 10 years to do. We've done it in just a few seconds. Well, we now begin to see our sun as one star in the Milky Way galaxy, our local collection of stars and gas. And here's what the Milky Way would look like if you went out of it and looked back. And it's a spiral pattern of gas and dust and stars. And in the Milky Way galaxy, there are roughly 100 billion stars, each as large as our own sun. And the distance from one side to the other is about 100,000 light years. Now, we're beginning to see the universe on the scale of galaxies. And galaxies, they cluster together. The way they cluster is very important for us to understand how the universe evolves. Our local cluster is a cluster called Virgo, and we're just about to pass it. There it is. And so all of these dots of light is a galaxy with 100 billion stars. How many galaxies are there in the universe? About 100 billion. So, easy question. How many stars are there in the universe? I know it's late on a Wednesday evening, but all you have to do is multiply 100 billion by 100 billion, and the answer is a lot. I mean, if you begin to imagine something like the grains of sand on the beaches of the world, that's roughly in the order of that kind of number of how many stars there are in the universe. Those of you from the Christian faith, just pause for a moment and think about Psalm 19. The heavens declare the glory of God. One of the things about God is God's extravagance or greatness. Now, we've gone back in much quicker because you saw the animation on the way out, and we found ourselves back in Chicago. And there, these folk are having a picnic. You can see, by the way they're dressed, what decade this movie was made in. You can tell by the way I'm dressed what decade I'm still stuck in. But one of the things about physics is the way that the very big is related to the very small. So let's continue our journey, this time making the size of the picture smaller by a factor of 10 every 10 seconds. Let's go into the man's hand and see what we can find. Well, you can see the layers of skin, you can resolve those with your own eye, but let's go and look at some more interesting things. So if we make the picture smaller, these are blood vessels. Inside the blood vessels, this is a white blood cell. Let's go inside the white blood cell. And this is the cell nucleus. And inside the cell nucleus, you'll start to see appearing the spiral coils of DNA, part of the stuff that makes us us. DNA is a complex molecule, but we're going to focus on one atom in that molecule. It's going to be a carbon atom. You'll see it beginning emerging here in the center of the screen. We're going to go into the carbon atom tonight. This is the carbon atom. There it is. And as we make the picture smaller, the first thing that we encounter are electrons. Now, in this animation, they're shown to be fuzzy. That's because of quantum theory. We haven't got time to do quantum theory this evening, at least in detail, but we move through the electrons, and in the center of the carbon atom is the carbon nucleus, so small that if the nucleus was the size of a soccer ball, the atom would be the size of a soccer stadium. I've said soccer there, I really mean football, but you know I'm from England on that. And the carbon nucleus is made up of protons and neutrons, and the protons and neutrons are made up of things called quarks. Can't show you what quarks are like because there's a particular nuclear force that keeps them locked in to the protons and neutrons. As you try and rip them out, the force gets greater and you can't do that. And that's about the end of our story. Now, you might have seen that piece of movie before. I've seen it many times, but it still fills me with a sense of awe at what this is all about. And if that's awe-inspiring, let's move on and say, where does it all come from? And our current model of the origin of all of this is something called the Big Bang. And the Big Bang is a nickname given to the theory by Fred Hoyle, a British physicist who didn't like this theory at all. He said, this theory has all the elegance of a girl jumping out of a birthday cake at a party. And he nicknamed it the Big Bang. And it's stuck ever since. And it says that some 13.8 billion years ago, the whole universe, everything I've shown you, 100 billion stars, 100 billion galaxies, all of it was small enough to fit through the eye of a needle. At that point, it begins to expand rapidly. On this slide, I've tried to put the whole history of the universe on one slide. Forgive me for being so bold. Our current age is 13.8 billion years. Some of us feel it more than others at times. And our current models of physics allow us to trace the history of the universe back in time with reasonably good confidence, believing that we know what the universe was like. So we think we know what the universe was like when it was only 1 million years old. That's a big jump. Those of you who are mathematicians, this is not to scale, by the way. In fact, we think we know what the universe was like when it was only 1 second old. And if that isn't sufficient, then we've got reasonably good confidence that our current models of physics work back right to 10 to the minus 43 of a second old. If you're not a mathematician, that's 1 divided by 10 followed by 42 zeroths of a second. If you're a biologist or an engineer or a normal person, if you know what I mean by that, you'll basically say, that's 0, isn't it? Well, not quite. At that point, our current models of physics break down. We can't go any further. That's very frustrating to scientists. It's as if you've watched the whole game and then just before the final decisive moment, your television blows up. You don't see the really interesting bit. But at 10 to the minus 43 of a second, the universe is very small, a fraction of a centimeter across. It begins to expand rapidly. As it expands, it cools. Quarks appear at about 10 to the minus 35 of a second. Between 1 second and 1,000 seconds in the visible matter, hydrogen and helium are formed, little bits of deuterium and lithium, but nothing much to write home about. And out of these big clouds of hydrogen, over billions of years, to cut a long story short, stars and galaxies appear. Now, you might be sitting there thinking, hold on a moment. David Wilkinson, how do you know that that's true? As the Lord said to Job in the Old Testament, where were you when I laid the foundations of the world? Okay, so here science is not something that you can do in a lab. It's more like a detective story. To pick a British detective, when Miss Marple appears on the scene of a crime, she's not seen the crime itself. She's not been there. What she has to do is look for clues or pieces of evidence to reconstruct what the best model is of what happened. That's what we do as cosmologists. We look for clues or pieces of evidence to reconstruct the best model. And those clues, we haven't got time to go into them this evening, but you might want to ask about them, happened throughout the 20th century. First of all, we saw that all galaxies are moving away from us, and they were redder in light than they should be. And then in 1965, Penzias and Wilson discovered a leftover radiation from the Big Bang, the microwave background radiation. And then in the late 1980s, we measured the amount of helium in the universe and found that it was in good agreement with our theoretical models. Now, hear me right. This does not prove the Big Bang. In fact, at the level of science that we do, you never talk about proof in this context. You talk about the evidence and how good the model is on the basis of the evidence. But the evidence for the Big Bang is pretty good and pretty sound. But it doesn't mean that we know all of the answers to every question. We've been able to look at this microwave background radiation, and the results coming out of it have been very good for the Big Bang model. But we've also discovered a few things that we don't know. Some of the big questions we're still left with. So we know that about 25% of the universe is in the form of something that we call dark matter. but we don't know what it is. That's why we call it dark matter. It's a kind of matter that doesn't give out any light, so we can't see it. We know that it's there because of gravity. Now, it's quite embarrassing for an astrophysicist to say that 25% of the universe, I don't know what it is. But that's even less embarrassing than having then to admit that another 70% of the universe is in the form of dark energy. And we call it that because we've no idea what that is. Now, that means, it doesn't take a lot of maths to do this, that I stand before you this evening only knowing what 5% of the universe is made of. And you may be thinking to yourself, he's got a cheek, this man from England, coming and talking to us about the universe, and he only knows what 5% of it is made of. But at least we know we only know what 5% of it is made of. And then there's this other question. Do you remember I said that our laws of physics break down at 10 to the minus 43 of a second? We don't know what happens at the very beginning. Now, the reason for that is going to involve me explaining to you both general relativity and quantum theory in 30 seconds. Are you ready for this? Yes, I hear you all say, at least those of you who are still awake. The two great theories of 20th century physics are these. General theory of relativity, discovered by Albert Einstein, describes the universe on the very largest of scales. Stars, galaxy, and the universe itself. And wherever you use it, it works beautifully. In the 1920s, we began to understand that at the very smallest of scales in the universe, there's a thing called quantum theory. And wherever you apply quantum theory on the smallest of scales, protons, electrons, it works beautifully. And most of the time, the folk who work on general relativity work down one end of the corridor, and the folk who work on quantum theory work down the other end of the corridor, apart from at one point in the universe's history. Do you remember I said, when the universe is very young, it's very small? Oh, says quantum theory. Small? That's my area. Just hold on a moment, says general relativity. This is about the whole universe. This is my area. The trouble is that these two theories at the moment don't cohere together. They are inconsistent. That's why we're looking for a quantum theory of gravity that brings together quantum theory and general relativity. And after 30 or 40 years worth of work, we still haven't got one on this. Now, what does that mean? Remember, it was very frustrating for scientists and continues to be. Robert Jastrow, in this book, God and the Astronomers, wrote a number of years ago, and forgive the sexist language, he wrote it a number of years ago. He said about this breaking down of the laws of physics, for the scientist who has lived by faith in reason, the story ends like a bad dream. They've scaled the mountains of ignorance. They're about to conquer the highest peak. And as they pull themselves over the final rock, they're greeted by a band of theologians who've been sitting there for centuries. Now, is that right? The fact that our laws of physics break down, is that where we put God in? Is this where God comes in? Well, just hold that for a moment. Now, my friends, are you all still with me so far? Roughly. Is this okay? Oh, I wasn't fishing for a round of applause, but it's very nice. Thank you. I've described the universe and I've described its origin in scientific terms. I want to go on now and talk about how this has led to questions about God, not just from religious people, but from folk who are scientists, who I know and work with, and would not call themselves religious at all. But before I do that, let me just acknowledge that within the Christian church, we have a diversity of view about some of these things. There are some Christians who read the first chapter of Genesis as a literal scientific textbook. And they interpret it and say, that means that the universe isn't billions of years old, it's a few thousand years old. And God created it over 6 days. There are other Christians who are equally committed to the authority of the Bible who say that the first chapter of Genesis isn't meant to be read as a science textbook. Now, for what it's worth, I'm in that second camp. And for me, the first chapter of Genesis is not a science text. I actually think the first chapter of Genesis is a hymn or a song of praise. So, Warren, if you had the writer of Genesis here this evening, who would be giving a far better talk than me, and someone asked, how old is the universe? I think the writer of Genesis would say, to be honest, I'm not really interested in that at all. What I'm interested in is that you know just how great God is. Now let's all stand together and sing a hymn of praise to God. But I do want to recognize that within the Christian church and within an audience such as this evening, there will be differences between us on how we interpret the first chapter of Genesis. I, however, am sad when those differences divide us. So I hope we can talk about those with graciousness and hesitation at times. One of my great heroes, Galileo, once wrote, "The scriptures are meant to tell us how to go to heaven, not how the heavens go." It's not a bad thing to remember from time to time. And sometimes that controversy amongst Christians drowns out those scientists who are asking questions about God. I'm going to pick out 4 questions tonight. And don't worry, it's not too much longer. The first question is this. And it's the question of origins. And it goes very bluntly, does the Big Bang prove God? Or to put it another way, if our laws of physics break down at 10 to the minus 43 of a second, is this where God comes in? You might have heard the argument which goes, if the universe began with a big bang, who lit the blue touch paper that leads to the explosion? Have you heard that argument from time to time? It was used by Pius XII, Roman Catholic Pope, in the 1960s, and by a wonderful Oxford mathematician called E.A. Milne. Not A.A. Milne, by the way, but E.A. Milne. And Milne wrote a brilliant book on general relativity, and to the end he wrote, "The first cause of the universe is left for the reader to insert." Now, is this a good argument for the existence of God? I have to say to you, in my view, it's not. I don't think you can prove God in this way. First of all, there are problems with the logic. They're about cause and effect being applied to the universe and what came before and time and all the rest of it. But more importantly for me as a Christian, this argument has 2 major problems. The first is what Charles Coulson called a God of the gaps. Coulson said, beware, if science has a gap in it, that you insert God as the explanation. Because increasingly, as science explains more and more of its own arena, God is pushed out of the gap and becomes irrelevant. The second problem is the problem of deism. Now, the deists believed in a God who started off the universe and then went for a cup of coffee, not to have anything more to do with it. Christians are not deists. They are theists. By which I mean, if you look at the pictures in the Bible, the pictures of God as creator are not about a God who starts off the universe, but a God who holds the universe in the palm of his hand, keeping it in existence, Hebrews 1. The images are not a God who smashes a champagne bottle against the hull of the universe and pushes it off to sea, saying, cheerio, folks, see you on Judgment Day. The image is more of God who keeps the whole thing afloat keeping it in existence. So in Colossians 1, Paul writes, "In him all things hold together, all things cohere." You see, the Christian understanding of God the Creator is not someone who simply starts it off. It's of a God who sustains every moment of the universe's history by sustaining the laws of physics moment by moment. And so when Stephen Hawking came along in Brief History of Time and said, "I want to try and find a model for the first 10 to the minus 43 of a second," well, he was unsuccessful, but if he'd found it, I would have gone, praise the Lord. Because it's simply filling in a bit more of the story of how God created the universe. We don't have to fear that. And Professor Hawking, by the way, if you think that quantum theory leads to a fluctuation which leads to an inflationary universe which leads to a Big Bang, and that gives you a full theory, where does quantum theory itself come from? You see, science assumes the laws of physics. It doesn't explain where they come from. And so even if we have a complete theory scientifically, it still begs the question where the laws of science themselves come from. That's a philosophical or metaphysical question, which for me the only answer to that's coherent is in a creator God. So does the Big Bang prove God? No, I don't think it does. But we're left with the question, what is the origin of the laws of physics? Second big question, the question of purpose. And this is, does the Big Bang disprove God? You've probably heard this argument as well. It goes, once I've got a scientific description of the origin of the universe, that's all I need. I don't need anything else. Professor Richard Dawkins takes that view of science. Once I've got a scientific description, that's all I need. But it seems to me that that's just a bit too simplistic. Let me use an old illustration. What is a kiss? Well, a kiss is the approach of two pairs of lips, the reciprocal transmission of carbon dioxide and microbes, and the juxtaposition of two orbicular muscles in a state of contraction. That is a kiss in scientific terms. But if I go to my wife Alison at the end of this trip and I say to her, "Darling, let's get together for a mutual transmission of carbon dioxide and microbes. Let me juxtapose my orbicular muscle in a state of contraction with yours," she would say, "Get lost." You see, in that context with my wife, the science is true, but it's not sufficient. In fact, to fully understand a kiss, I need to understand it not just in terms of carbon dioxide and microbes, I need to understand it in terms of meaning, value, and purpose. Which is true. Both are true, but different. And so if I have a scientific description of the origin of the universe, that doesn't rule out questions of meaning, value, and purpose. And so can you disprove God through the Big Bang? No. But we're left with the big question of purpose. Why is there something rather than nothing? Third big question, question of design. And that is there anything about the universe that kind of doesn't prove God but might point towards God? I think the answer here is possibly. For some, perhaps. One of the fascinating things in the last few decades, has been the discovery of anthropic balances, or what Paul Davies calls the Goldilocks enigma. The fact that the universe is just right for us to be here in the law and circumstance of the universe. Fred Hoyle, remember Big Bang? Didn't like it. But Hoyle discovered something that illustrates this. In the late 1960s, he understood where the atoms of carbon in our body come from. And they come from exploding dead stars. And Hoyle showed a remarkable thing. He said, if the energy levels of carbon were just 2% different to what they are, and if the energy levels in oxygen were only 0.5% different from what they are, then there would be no carbon in the universe. That's quite serious for you and me because we're made of it. And Hoyle, who was an atheist, wrote, "Nothing has shaken my atheism as much as this discovery." Now, there are various ways to look at this. Martin Rees talks about these anthropic balances and says, well, you can interpret them in different ways. You can say they just are, but they're so extraordinary. You could say God did it. Or you could say we're one of a multiverse of various universes, which we're just right. We're here and we observe it because we're here. And if you want to ask me about multiverse, we can come on to that in terms of question and answer, but I'm overgoing time at the moment, so let me move on. But I think we're still left with this striking fact of the universe. Doesn't prove God, but the fact that things are just right for some people might be an indication there's a deeper story to the universe. And then there's this question of intelligibility. Albert Einstein once said, "The most incomprehensible thing about the universe is that it's comprehensible." You've got to think about that for a moment or two. I mean, here we are in this beautiful Lakeland church, and we've been talking about the universe back to 10 to the minus 43 of a second, and it's comprehensible. Well, at least I hope a bit of it has been. I mean, why can we do that? Why can my friends down in the physics department in Durham where I teach, they simulate universes. They have vast Cray computers, and they start off with a universe with some dark matter and dark energy, and they let gravity do its work on it. And these are some of them. Let me show you one, because I'm a nerd and I love these. Don't worry about the colors. The colors tell you different temperatures of the gas. And this is gas beginning to form galaxies. You begin to see some of the structures forming here, and some clusters of galaxies begin to form. And by using some very simple laws, they simulate very well the clustering of galaxies that we observe in the universe. It's remarkable that they can do this in a computer in Durham University in the northeast of England. These are clusters of galaxies. And we can even understand how galaxies themselves form. In a moment, we'll switch scales, and we'll look in this simulation to one galaxy beginning to evolve just in this picture. So here we go. Again, don't worry about the blues colors. The color contrast just tells you the different temperatures of the gas. It just allows you to see what's happening. And you see here in the middle the gas collapsing under gravity. And here we're zooming in. Here's a little concentration of gas and stars. This is going to become a galaxy like ours. Do you see how chaotic it is, with stuff banging into each other? But the rotation and the force of gravity slowly starts to form this spiral disk galaxy like ours. And there it is. Now, I could show you this for hours and hours and hours, and be far more interesting than my talk. The most incomprehensible thing about the universe is it's comprehensible. And then, what about this sense of awe? I hope you've had a sense of awe tonight. Have you? I hope so. Now, science isn't always about pretty pictures. Most of us who are professional scientists know that most of science is boring, frustrating, tedious, and really disappointing at times. It's about peer-reviewed journals who don't acknowledge just how brilliant your paper is. It's about governments who don't fund you for the experiments that you want to do. It's about PhD students who don't do what you tell them to do. It's about going to a telescope and finding that the next 3 nights are all cloudy. But there are moments in the midst of all of that which are wow moments. where you see that underneath the complexity of what you observe are some beautiful, simple, elegant, universal laws. Now, these wow moments, this comprehensibility, this sense of Goldilocks enigma, for me, are not proofs, but pointers. And that leads me to my final point, and that is the question of revelation. Because you may say, okay, David, you can't prove God, you can't disprove God. I get the KISS thing, you can have God and science. You've said that there may be pointers, but how is this God known? Is it simply by something we call faith? And Professor Dawkins, in his characteristic humility, said, faith is the great cop-out, the great excuse to evade the need to think and evaluate evidence. Is that where the God bit comes from? I don't think so. For me, it was the recognition of something very, very important and very profound for me. That if the infinite God wanted to communicate with us, finite minds, the best way that God would do that would be through becoming a human being, Jesus. And so when John begins his gospel, sometimes here at Christmas, sometimes here at other times, when John begins his gospel, he doesn't begin by saying, oh, by the way, I knew this man, Jesus. John does something quite remarkable in terms of ancient philosophy. He takes two strands of the ancient world in terms of their understanding of the word logos. The Greek understanding of the word is the rationality behind the universe. But he puts it together with the Hebrew understanding of the word, which is God's personal creative activity. Do you remember in Genesis, God said, and it was so. And John puts these two things together, and he writes, in the beginning was the Word, and the Word was with God, and the Word was God. And you think to yourself, John, what an amazing thing to do, to say that the rationality behind the world is because of the personal creativity of God. Wow! But before we can stop wowing, John goes on and says, and the Word became flesh, a human being. He moved into our neighborhood, and we beheld his glory, glory as of the only Son from the Father. No one has ever seen the Father, the only Son, he has made him known. It was my encounter with Jesus, both in the pages of the Gospels and in personal experience, that's allowed me, in the many questions that I still have, in the little bit of science that I know, in the little bit of theology that I know, to find a God who exists, a God who is creator, and a God who is love. I think I should stop there, and thank you very much.
Thank you, Dr. Wilkinson. We do have an opportunity now for a question and answer. So I want to invite you. We're going to, because I know that there's dozens of questions here amongst all of you. So I just want to invite you to queue up here behind the mic and ask your question, and we'll take as many as we have time for. That's until right. People start, heading for the exits. No, but right. Please, if you have questions, just come here. I'll be nearby so I can adjust the mic level if I need to. Here comes Gwen. Thank you for breaking the ice.
Hi, my name is Gwen.
Hi, Gwen.
Something that I have been using to explain some of this to people, I'm not an astrophysicist, but I'm a scientist.
Wonderful.
The part where you said it's 10 to the 43, I've always told people that That's as far back as we can actually get. And to me, that means that that time before that is where God is. Does that make sense?
Well, it does, in terms of that I think we always have to say that God is beyond the scientific picture. There's a more than God. The thing I would be cautious of is if Stephen Hawking was able, he wasn't able to, but those who followed him, was able to fill in that scientific explanation of the first 10 to the minus 43 of a second.
Yeah.
Now, if that happens, if you have put all of your eggs in that basket, particularly trying to prove God, which I know you're not doing, then immediately that ground for proof of God is taken away. But if you see God as the one who establishes the laws by which even 0 from 10 to the minus 43 of a second can happen, God is the one who provides theories of general relativity and quantum theory, I think you're on much safer ground.
I like that.
But I think your point, Gwen, is really important in terms of science does have limits to it. It doesn't answer every question that we want to ask of life. And sometimes some of my fellow scientists, not many, but some of them, will basically say that science will give us an answer to every question. I love science, as I hope I've demonstrated, but it doesn't answer every question. So thank you.
I agree with that.
Thank you. Yeah. Good. These pews are not easy to get in and out of, are they?
Thank you so much for your presentation. I don't have a question, I have a statement.
Please.
I have a doctor of philosophy,
Great.
a nurse scientist,
Yeah.
and I gave up that particular career in my life after 9 years of research, and my research just kept leading to more and more questions. And I said, you know what? I stop.
Yes.
And I'll just be
Yes.
and enjoy that which is held where I'm held
Thank
by
you.
his hands.
Well, thank you, first of all, for that comment testimony, and thank you for your work also. But I think there is something about that we can become so obsessed with finding answers that we lose the sense of simply being, as you wonderfully put it. So that, in my experience, very few scientists are completely dedicated to science, by which I mean that there are other parts of their lives, whether it be family or soccer or art, music, cinema, that remind us that science is a fully human activity. It is done by human people. And I think we value that as a society. I think the other point of what you've made, which is really interesting, is that, and I mean, those of you who are science teachers here this evening, I want to say thank you for the work that you do as Christian folk. But sometimes in the UK, I don't know what it's like here, when we teach science, we've got so much to teach that we give the impression that science is about a certain set of answers. You've got to know the answer to this, you've got to know the answer to that, you've got to know the answer to this. Whereas the really great scientists are the ones who are able to see what questions are important to ask. And at the heart of really good science is the ability to know what are the questions to ask. Now that is an opening up rather than a closing down. And within the UK, one of the great things I'm worried about is the way that we teach science doesn't allow young people to see that this is a fascinating activity where we ask questions. Now we do get some answers, wonderful answers, but actually that openness to exploration and it being part of our very humanity, really important. Thank you.
Tell them what you're currently doing with equipping Christian leaders.
Okay, my plant in the audience here has just asked me the question. What am I currently doing in the work that I'm doing at the moment? And I'll tell you that before there's a question here. About 10 years ago, a friend and I felt that when Christian leaders, senior Christian leaders, and by which I mean bishops or leaders of big Christian organizations, again in the UK, when they were asked about science, they often were negative about science, fearful about science, or silent about science. And we felt that if your senior leader was like that, it had a ripple down effect through the church. So if you're an engineer or a biology teacher in a congregation and you felt that your senior leader was negative about science, then what does it mean for you as a Christian working day by day as a scientist? And then, of course, that rippled out of the church and reinforced the conflict model between science and faith. And so we began a project where we called Equipping Christian Leaders in an Age of Science. I might even have a slide up here. There we go. We work, there's the website if you want to have a look at it. And we work with a team in the UK with the Church of England and the University of York. And we also now have international partnerships with Singapore and Kenya and Poland and Bangalore, India, where I was just a little while ago, because we want to learn together how Christian leaders view science in different contexts. And I'm learning a lot. Thank you, Paul. So you were on your way to ask a question or make a comment.
Yes, thank you. I really appreciated your talk and the elegance of it. And I'm a theologian type person.
Right.
And my question is, it seems that when you start with science, that you might get too optimistic. That is, you're talking about the elegance, and this provides a place for us to be, and all that's true. But it also is the case that it's going to kill us.
Yes.
That is, the whole universe that gives us space is also, at the end of the day, individually and in terms of the cosmos as itself, it's going up in either a frozen nothingness or a ball of fire or something. We'll be gone long before that in any case in our little space. But so my question is there a danger in starting with science? And I read more scientific journals than I do pop scientific journals, and I do theology books these days. But do you think there's a danger in stressing the importance of science because people might reject the faith before they ever get to John 1? And of course, I'm the type of theologian that wants to start there.
Yes.
With our faith is grounded in God's revelation in Jesus. Yes. And then we can enjoy and understand that science doesn't contradict that, but it also doesn't answer the theological questions that are saving or that even take us there to faith.
Thank you so much. Really helpful. And it's a very rich question. So I won't do justice to the whole of it, but let me just take what for me are the important points to respond to first. I think you're absolutely right of the danger of starting with science. And remember when I talked about design, I talked about pointers, not proofs. So David Hume's classic critique of the design argument, which became very popular for Christians, was you're taking all the good bits of science and you're forgetting all of the evil parts of the world, suffering. You very helpfully extended it to the end of the universe. By the way, if you want me to come back and talk about the end of the universe sometime, I'm very happy to do that, because that's a very important issue. But you're right, Hume was right, that if that's the only way you're trying to get to God, then the problem of selectively choosing certain types of science means that and we know that the design argument didn't work. And when Darwin came along in the 19th century and gave an alternative explanation for design, the whole thing crumbled. And therefore, I'm very worried, and I don't want to step on any toes here, forgive me if I have, I'm very worried of those Christian sisters and brothers today who want to reform the design argument in something called intelligent design. It seems to me that that has all of the problems, both of God of the gaps and of the critique of the design argument, which you've eloquently said. And I do, in a sense, theologically always want to start with revelation. That's the only way that we can know God. But in my own apologetic kind of work, for what it's worth, I follow what a friend and mentor of mine, John Polkinghorne, called bottom-up thinking. And John said, start with a specific in science and be real about it. And he said that for two reasons. The first is, he said, you're more likely to get an audience talking about the Big Bang and the universe than if you're giving a lecture on the doctrine of the incarnation. I mean, he might be right or wrong on that, we don't know. But secondly, he said that if God is creator of all things, then you can start with the specific and move through. And so when I've given this type of approach elsewhere, some Christian folk, I think with good sense, have said to me, well, you know, you left the revelation thing right to the end. Do a bit more about it. Well, I will do a bit more about it. But in a sense, this is the first step. And I think, coming back to, I mean, we can only speak with revelation on the table. So some Christians in the science religion debate will not even bring incarnation revelation to the table. They'll simply sit with the science and with God in the general, in the specific. And in Dawkins' God delusion, Dawkins actually does away with any sense of revelation, and he finds himself back in the design argument and all the rest of it. So I always want to come with Jesus to the table. That's what I bring as a Christian. And not be worried about that. To offer as a gift, rather than you need to believe this, for exactly the reasons that you eloquently said. And the Jesus of the incarnation is the Jesus who becomes incarnate in the messiness of the world. Not just the beautiful sunsets, but the cross. Not just in the wonderful, insightful teaching, but also in getting his feet dirty and grimy in the mud of Palestine. And so the incarnation allows us to deal seriously with this admixture of a world that is both good and fallen, that is both beautiful and broken. And for me, the incarnation only does that. The final point that I'm sorry, forgive me for going on so long. The final point that struck me was a really important challenge, and that is, might people not get to the incarnation and be stopped by the science? The flip side of that is that many people actually don't get to the incarnation because they think the science doesn't allow them to get there. So part of this, I think, is us saying that science that conflict model talks about is not really there. So let's just move that out of the way and let's see what we make of it. Thank you, really helpful. Any other questions? Don't worry, I won't give an answer as long as that to everything, but really helpful. Other questions, comments? Thank you. Yeah, someone here and then someone here.
Thank you for your presentation. It's always been an interesting topic to me, and around a beer or two or dinner, people would say, well, there is no creator because it's the Big Bang and there was nothing. And I always would respond, I'd say, well, what was there before there was nothing?
Yes.
And there is no answer, and then the other comment that I read by an astrophysicist said made more sense to me than anything, was if this universe was randomly created, why are we not running into each other in the orbits, the moon, the Jupiter, the Earth, and so forth? And I'd like to hear your comment on that.
Well, thank you.
That it was obviously designed, or else we would be random. Thank you.
Thank you. One of the fascinating things, thank you very much. One of the fascinating things about the nature of science is the way that law and randomness interact. That actually, randomness within the universe, or uncertainty, gives a degree of novelty to the universe. But you need the laws of physics for that novelty not to become, and I use the word in a non-technical way, chaos. There's a technical way of thinking about chaos. So randomness and law have to go together in the creative process. And so we can know something about the orbits of the planets, but how the gas collects first of all for the solar system to form, and particularly which way it's rotating, that's something that just is. Now, what I want to say is, let's talk about where the laws come from, as a way of saying, is there a deeper story to the universe? Because we know that the universe has structure to it. My friend asking about the future of the universe, one of the interesting things is the way that structure will decay within the universe. But just at the moment we see it and we recognize it, and there's something about it. So thank you. I think that's really helpful. But I'd like to point to, where do the laws come from? The laws of science. Thank you. Yes, sir.
I'm always too tall for the microphone.
Yes.
My question, I just love thinking about this kind of stuff, and one of my favorite topics is, given the scale of the universe and the existence of the Goldilocks conditions to support life, do you think that life is limited to just here on Earth, or might it be elsewhere? And then what might the theological implications of that be?
Yes, thank you, sir. This is a huge question, and it would be terrible for me to say, I've written a book on this. And I'll tell you the answer of the whole book, so you don't have to pay the exorbitant amount of money that it's charged. And that is, I don't know. But let's just break it down a little, because this is such an important question. You said size of the universe, Goldilocks. And there is a sense in which, particularly in the last 20 years, we've discovered planets around other stars, exoplanets. And it looks as if about 70% of stars have planets. And a percentage of those are rocky planets, a bit like the Earth. Well, I said there were 100 billion stars and 100 billion galaxies. So that's a lot of possibilities. But 3 problems. The first, it's a long way from an amoeba to an accountant. Or maybe not. Anyway, it's a long way from primitive life to complex, conscious, intelligent life. So we could have a universe with primitive life in lots of places, but we know that things have to be just right for a long process of evolution to lead to conscious life. Second problem is what's called the Fermi paradox. And the Fermi paradox from Enrico Fermi said, if they existed, they would be here. Because he calculated that the time taken for an alien civilization to colonize the galaxy would be short compared to the time of the galaxy itself. Now that leads us into questions of encounter with aliens, whether we are a visited planet or not. That's a whole area of discussion. But the third possibility, or third caution, I guess, is we're talking about very large distances between the stars here. Now, if there was a civilization in our closest galaxy, Andromeda, and they sent a message saying, hello, is there anyone here? That would take 2 million years to reach us. If we then send a message back saying, we're here, who are you? That's another 2 million years to get back there. That's not a very interesting conversation. And one of the problems is that it could be that there are civilizations which are far beyond our ability to actually know whether they're there or not. Now, each of those points about the development of conscious life, whether we've encountered aliens, problems of communication, those are all in the area of conversation. But you asked right at the end, theologically, what this might mean. And to that, I'm a little more positive. In terms, I wouldn't find it in any way a threat to my Christian faith if there was other life elsewhere in the universe, or we encountered intelligent life. And that's for a couple of reasons. The first is that in the 16th century, Nicholas of Cusa, a theologian, said, we are special, not because of we're at the center of the universe, but because of the gift of relationship with God. So we're special not because we're alone, but because God has reached out to us and we've seen God in Jesus. And that means that we don't have to worry about human status if there are other intelligent life forms elsewhere in the universe. When I sit at dinner with my family, I don't need to sit at the top of the table to feel special. I can sit anywhere I like because I know I'm loved. And my love for my son is not exclusive, which means I can't love my daughter as well. So Cusa was right. The second thing is a bit more complicated, and that is, what would the significance of the Jesus event be for other intelligent life? And that's where Christians have disagreed and continue to disagree. And it depends on whether you think that the once-for-all nature of Jesus dying on the cross is for the whole universe, in which place we're on a long cosmic missionary journey, sisters and brothers in Christ, of taking the gospel elsewhere, or whether you think that God becomes incarnate on other planets. If there are little green women and little green men out there, did God become incarnate in little green flesh? But that depends, as C.S. Lewis in his science fiction pointed out, on whether other beings fell into sin in the way that we did. Now that means that on that, I'm not too sure. John Polkin, who I mentioned earlier, was once asked this, and he said, to be honest, he said, the God that I see in Jesus would do what is necessary. I don't think that's a bad answer. I'm sorry, that's a whole lecture contracted to 5 minutes. Is that okay?
Thank you so much.
Thank you. Are we still going? How are we doing for time?
Okay, if I understood you correctly, you said we don't know God empirically, but through revelation. And I wonder if you could expand on that a bit. Would that include visions, near-death experiences, things of that sort?
Yes, thank you. Thank you very much for the question. Christians, when they think about how God is encountered, particularly in terms of revelation, say that, as the book of Hebrews would say, that God's revelation in the historical events of the life, death, and resurrection of Jesus Christ is God's supreme way of revealing himself to us. But there are, throughout Scripture, as you rightly said, many other ways in which God communicates. The incarnation, the historical events, the life, death, and resurrection of Jesus are the plumb line by which we judge some of these other visions, dreams, angelic appearances. The Bible is full of these, and religious experience as well. Our direct experience of God in Jesus and the power of the Holy Spirit within us. So when I talk about revelation, I'm meaning at core the life, death, and resurrection of Jesus of Nazareth. But also that different religious experiences are part of that. And that God relates to individuals in different ways. Now, I became a Christian at the age of 17 for a number of reasons. First of all, I was desperate in love with a girl who went to the local Christian youth group. And so I started to go along to that church to try and go out with her. I can see a number of people nodding. That was your experience as well. I never got to go out with her, but I found amongst these Christian young people something that was different that I'd not experienced before. Couldn't quite tell what it was. Second thing, and this shows how old I am, Bob Dylan went through his Christian phase. I was really into Dylan. And suddenly, I heard about Jesus in a language and a culture that was relevant to me. Before that, I only thought you could sing about Jesus in the words of the 18th century. Suddenly, it was in my language. The third thing was I began to read the New Testament for myself. Much of it I found incomprehensible, but the story of this man Jesus, what he taught, how he lived, his death and his resurrection, led me to that point where I thought this can have no other explanation than this is God himself walking the pages of history. Now that was an intellectual kind of process, but there came to a point where actually the experience has to go along with the historical revelation. And in a little Methodist chapel, I felt the experience of the Holy Spirit drawing me to make a commitment to follow Jesus. And that goes beyond science. You know, if I ask the question, as a scientist, how do I know that my wife loves me? Well, I can look for evidence. Does she buy me a Valentine's card? That would be evidence. Does she scream and run out of the room every time she sees me? That would be a different kind of evidence. But the only way that I know that I am loved by my wife is if I come to a point where I trust myself into a relationship. At that point, love becomes real. Not just evidence, but experience. Now, evidence and experience, I think, is at the heart of Christian revelation. The evidence of the events, primarily of the life, death, and resurrection of Jesus. The experience that we have of a God who is not confined to the grave, but is risen and alive. And therefore, I want to hold those things together. So, when folk come and sometimes ask me, well, I had this experience of this, that, and the other, and some can be quite bizarre, then I want to ask, what's the relationship to Jesus in that? And when I talk with folk who've read the text, they've read the Gospels, they've thought this is really interesting, I want to invite them and say, well, there's something more to it in Christian faith. Have you prayed and said, Jesus, be real in my life? Evidence and experience. Hope that helps.
I'm going to let Ivan ask his question here, but I just want to say this will be our last question here because I know the choir needs to get in here to rehearse.
Of course, absolutely.
They have an anthem with
yeah, and you've heard my singing voice. Yeah.
So once Ivan has the opportunity to ask his question and Dr. Wilkinson has an opportunity to respond, we'll head over here to the bookstore, which is just on the other side of the courtyard where the fountain is, and invite you to come and greet Dr. Wilkinson if you have additional questions. And
sure.
Perhaps he'll have the opportunity to answer them there. And we do have copies of some of his books over there as well. So, Ivan?
So my question has to do with the relationship between revelation and scientific discovery.
Yes.
And if we believe in a God that is intimately involved in our universe and a creator of our universe and everything, how do you view the idea that scientific discovery may have originated with the mind of God? Because we're not that far removed from discovering fire to figuring out that there are subatomic particles. I don't think we're that smart. Anyway, let me throw that out there for you.
Thank you. And I mean, it's a wonderful last question. And I'm going to say, I agree. For me, science is gift from God. Now, that doesn't mean that at times it's an easy gift to use. Sometimes we have to work hard at using the gift well, both in terms of using it to discover, but also